Good morning, Mavericks. It's Mr. D, and this is the part of the video I promised I would be sending you this weekend. It has additional information on graphing the ellipse, so let's get rocking. The first problem is we want to graph the conic section defined by the equation 9x squared plus 36y squared minus 72x minus 180 is equal to 0. That's not written in standard form, so over the course of the next few minutes, we're going to get that written in standard form. We're going to graph it, we're going to find the foci, and we're going to point out some possibilities for follow-up questions. So, first move in getting this written in standard form is we're going to group the x terms together, which is where we get 9x squared and the negative 72x. The 36y squared is over here. There are no other y terms, so I'm just going to leave the 36y squared. And this negative 180, I'm going to move it over to the right-hand side and make it a positive 180. Now, the next move, and we've been doing this with the circle, is we're going to have to get this written in standard form through completing the square. However, we can only use the process of completing the square when the leading coefficient, the number in front of the x squared, is a 1. Since that's not the case, we're going to factor out the 9. So out of 9x squared, we take 9, leaves me x squared. Out of the negative 72x, we factor out the 9, leaving me a negative 8x. And then we're going to work to figure out what the magic number is here to make x squared negative 8x plus something a perfect square trinomial. Since there are no other y terms, just the 36y squared, this one's going to be easy. Still equal to 180. Now let's actually find that magic number that makes x squared negative 8x a perfect square. The process is we take negative 8, we divide it by 2, that gets us negative 4, you square it, negative 4 squared is 16. We're going to add 16 over here inside the parentheses, but when we do that, we're going to have to keep in mind that if I've added a 16 on the left, I would add 16 on the right. But hold on. If I'm adding 16 in the parentheses and that 16 is getting multiplied by 9, the effect is I've actually added 9 times 16 on the left, so I'm going to have to add 9 times 16 on the right. Okay. X squared negative 8x plus 16 is now a perfect square trinomial. It's actually x minus 4 squared, so we get 9 times x minus 4 squared plus 36y squared equals 324. If we're going to make this a proper ellipse, we need this number over here to be equal to 1. So we're going to divide everything by 324, which is what we did there. And then when you actually reduce 9 and 324, share a common factor of 9, which gets me x minus 4 squared over 36. 36 and 324 share a common factor of 36, which gives me y squared over 9. All that's equal to 1. That's actually in standard form for an ellipse. Now, before we actually go and graph it on our graph paper, let's just review how we Okay, now that we have written that ellipse in standard form, let's review our notes. For an ellipse written in standard form, x minus h squared over a squared plus y minus k squared over b squared equals 1, h and k are going to give us the coordinates for the center of the ellipse. The a, so that's going to be not the a squared, but just the a, so we're going to have to take a square root, we're going to generate the horizontal axis of symmetry by moving left and right a spaces from the center. To generate the vertical axis of symmetry, we're going to move b spaces, again we're taking a square root of the denominator here, up and down from the center. So I'm going to take all of that and actually graph my ellipse. So here we go. Great, now that we've got that information, let's finish graphing the ellipse. We have x minus 4 squared over 36 plus y squared over 9 equals 1. I'm going to look for h and k. H is going to be 4. K will be 0 in this case. That's my center at 4, 0. Since the denominator of the x minus 4 squared is 36, I take the square root of that, which is going to be 6. That's the a, and as we discussed earlier, I'm going to move 6 spaces to the right. That gets me to 10, 0. I'm going to move 6 spaces to the left. That gets me to negative 2, 0. That is going to be my horizontal axis of symmetry. Under the y squared term, we have 9. That's the b squared. In order to get b, we take the square root. Square root of 9 is 3. So we go back to the center. We're going to go up 3 spaces. We're going to go down 3 spaces. That gets us to the point 4, 3 and 4, -3. If I were to connect those 2 points, that's going to get me the vertical axis of symmetry. This is what we're going to refer to as the hamburger ellipse. It is wider than it is tall. All right, so back to our notes. I mentioned